All right, students, the technical mathematical term for this topic is called computational balloon twisting. But seriously, we get to talk about balloon art in a math class because there is legitimately math involved with balloon art. I seriously never knew this, and I have been a math teacher for like 21 years. We're going to keep it pretty light on the math, but the idea of networks really does come into play. And so balloon artists, they have done this through trial and error. Some of them know like when they can do the shapes and just through practice. But there's actually a lot of research and math studies that go pretty in depth in the math behind balloon art. So that's why they came up with computational balloon twisting. They make it sound so hard when it's so fun and cute. So these obviously are just for visual picture references. The flowers, some of the simple ones like the hedgehog, things like that, you can tell that there is more than one balloon involved. So when I talk about balloon art, we're going to keep it pretty simple. But some of these complicated designs you could just go crazy with. So let's talk about probably the most famous balloon art is the dog. So keep in mind, any animal that's made from a single balloon, it really is that Euler path. So think of, they take those, if you've ever seen a balloon artist, they take a big long one balloon, and sometimes they can just use one shape and they can make a creation from it, balloon art. That would be a Euler path, since you don't have to start and stop at the same spot. Some swords might, things like that. But when you twist them, you can think of where they're twisted, like here and here and up here. They're joining, like these would be edges. Okay, so when they have different shapes, wherever they're being twisted, that is your vertex. All right, so the circuit, we would have to take one balloon and we would have to fold it and twist it in different ways to where they would end up at the same spot. That can happen for some shapes. I think of like swords. Sometimes that takes more than one balloon. So then that's not going to be a circuit. All right. So what we can do in this class though, is if we take a picture of a balloon art or balloon animal, we can make our own network that's two-dimensional. And so that's what we've done right here. So see how we just kind of see where are they twisted together, and we made those the vertices. Okay. And then where you see the shapes being touched, that makes your edges. And so even though we know like a dog's legs, they're not really connected, you have to use your imagination just a little bit because you're taking one balloon and we're making it into this shape. So this would be our network. Okay. Now, since we don't start and stop at the same spot, this is going to be an Euler path, or just a path. Let's just say that. We'll just call it a path. So I could say like A to B to C to B, and we could go all the way around if we labeled these with letters. Okay, so that's the idea. I actually bought my own children balloon animals once for their birthday, the big long things, and a book and a video, and we made some, but I literally never realized that it was a network. All right, so some math to consider. The balloon dog above, it would have the same graph even if we had a longer balloon or if it was a different dog, if the legs were different sizes. So we're not going to make these weighted paths. That's how that could apply, okay? It could be a different shape a little bit, larger loops linked with each other, things like that. Now, there is a way mathematically we need to figure out, well, how do I know how many balloons I need? Well, if you don't physically have balloons to experiment with through trial and error, there is some math involved, and people have actually calculated that, okay? Can you figure out a rule that will let me know the minimum number of balloons I need? Through experimentation, it might be the easiest way, but there is a mathematical way. So you might discover that they need to put, sometimes they put like the balloons in the middle of an object, and they are actually doing that Euler's path and circuit idea. Like, oh, if this has like two edges coming out and I need a third one, you know what I mean? So they're kind of doing that behind the scenes. So mathematically, someone figured out how many balloons will we need for our balloon art. So because each balloon, when it starts out, it really is a long, skinny balloon. It has two ends, so that's like our vertex. Then the number of balloons that you'll actually need can be taken by this formula. You're going to find the total number of vertices that have odd degree and divide it by 2. All right? So I'm not going to have you necessarily do this, but I think it's interesting just to learn about that there really is math involved. Okay, so I kind of want to just go over some of the shapes because this is what you're going to do on your project. So on the internet, and please don't use any of these pictures for your project. The first one is called an octahedron. And so it is a 3-dimensional shape out of more than one balloon, but we'll figure that out later. And so we've got vertices right here, and then they just drew this shape. Now, it does take some skill, and this is actually discussed a lot in math research, because even though mathematically I can draw a picture, but to actually physically get the balloon in some of these spaces, that definitely takes skill. And sometimes you're like, well, mathematically it's possible, but physically it's actually not. So there are some limitations between the math and the reality. All right. And so you might need a longer balloon, but we all know there's limitations with that as well. All right. So my next picture is called a triangular dipyramid because there's 2 pyramids and they're in a triangular shape. So remember, a pyramid from a math class has a square base and they all go to one point. So they did this pyramid at the top, except we're using a triangle as the base. And then they did the same thing on the bottom. So that is called a triangular dipyramid because there's 2 connected. And so we can have our vertices. You kind of see here, 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 here. I'm not the best. I would draw my middle first, and then we can draw. Okay. And then the bottom one is even harder for me to draw, but that is a octahedron. It is one balloon. One really, really, really long balloon. Okay, this is probably a really tiny picture just enlarged. And so there's so many of these little vertices. Okay, so normally a balloonist, they only partially inflate a balloon, if you've ever noticed. And I always wondered why. So really, if you, I don't know, go to a carnival, kids' birthday parties, it's kind of not always easy, but there's tons of YouTube videos, and I would suggest you watch those. They're kind of fun and interesting. They take a balloon and they always leave like an end, and sometimes it's longer than others, and I'm like, how do they know how much to leave? But I'm not a balloon artist. So then they start twisting it to get those edges and the vertices. Or they might take 2 balloons and they might weave them together and they might make some shapes. You know what I mean? So they really do know. But like here, they know where to twist them together. Like in their head, they're visualizing what they need to connect, how many they need to. And so like this one, you can see it definitely has 3 balloons minimum. It really actually has 4 because you can see this blue is not connected to that blue. So this would have 4. But like this vertex has 1, 2, 3 edges. This one has 1, 2, 3, 1, 2, 3, 1, 2, 3. So they all have 3 edges. And there's 1, 2, 3, 4, 5, 6, 7, 8. So remember, I have 8 odd vertices, and I'm doing this picture. And so if I divide by 2 by the formula, it means I need 4 balloons. Okay, so see how that works? This one has 1, 2, 3, 4 vertices. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So there's 4 odd vertices, and we divide it by 2, which means I need 2 balloons. I literally just think this is amazing. Like, you can figure it out mathematically. It kind of blows my mind. And they do more complex here. So I'm not going to count these out, but you can see some of these have 1, 2, 3, 1, 2, 3. And so it's a dodecahedron, and they used 10 balloons. But we could count all these vertices and divide by 2. Okay? So that means there's 20. 20 vertex, and they divided by 2. Dodecahedron. Isocahedron, if I use 6 balloons, that means there were 12 vertices. Okay? Seriously, this is, I don't know if this is amazing you, but mathematically I can do this. Now, physically, I would definitely need a lot of practice to do this balloon art. But I think it's so fun. Okay, so what I want you to do for your project is you're going to open up this Google slideshow. So the opening slide is called the Balloon Art Project. I just have some pictures here. You want to keep your project pretty simple, okay? So some of the pictures that I had like on this one, those are crazy complex, okay? So find a simple picture on either Google, or if you go to YouTube, let's go to YouTube, and I'm just going to search in balloon animals or balloon art. You'll find quite a few pictures, okay? And so you can use some of these, and as you watch the video, it'll show you more in depth, like what the picture is made out of. You can just screenshot a picture of any of these, okay? So just pick something simple, but don't do any of the ones that are in that last slideshow, okay? So what you're gonna do is, on the first thing, this tells you all 3 parts. So you're gonna find a picture. Okay, I said keep it simple, go to Google, go to YouTube, search balloon animals, search balloon art. Number 2, you are going to create a network, and that's a 2-dimensional drawing, and then you are going to figure out how many balloons you need. So on the first thing, you would insert your picture right here. Then on task number 2, you can, if you go up here, I can insert a shape. So I can insert a circle as my points, or I can also go to this segment and I can do curves. Okay, so like if I just put extra dots here, so you can move these around. And the whole idea is that you want to create this. Okay, so like these would be my circles. And then if I do this little curvy line, I can go from here to here, okay? And then we can kind of connect them together, all right? So, oops, I'm gonna hit escape. I'm gonna get rid of that. So I'm gonna move these back because this is my original. Okay, if you don't want to use these dots and you want to make your own, that's fine. You could also go to insert drawing. Where's drawing? Yeah, what diagram? Oh, image. No, there was a drawing. That's so weird. Okay, well, it's available in Google Slide. I guess it's not available here. Okay, so you want to use those shapes to create your 2-dimensional drawing of whatever picture that you picked. Okay. Then on task 3, I'm going to ask you, well, would you need 1? So remember, if you need 1 balloon, it means that all vertices have to have that even degree. Okay. If you need more than one balloon, then you're going to figure out how many you need. So remember, you're going to take your total number of vertices with odd degree and divide it by 2. You might even see, if you pick a video one, how many balloons they used, so you can count them. All right, that's it. Okay. Go ahead and watch the Zoom. I'll do an example with that this week, and email me if you have any questions. Okay. Hopefully you have fun with this. I thought it was a super cool topic, so I definitely wanted to include